So we're going to be doing the second part of our exponent laws lesson today. And this do it now here is just a reminder of what we did yesterday in our lesson. The first one you can see is a product rule. So if you look at your notes yesterday, you can figure out what you should do with the exponents. Remember, the start of every rule is keep the base the same. So in this case, my base is 3, and I have an exponent of 2 and an exponent of 5. So go back and look at your rules, figure out what do you do with the product rule, how do I simplify that, and then plug it into your calculator and evaluate to see what that actually does equal. For the second one, you have y as your base, so you can't evaluate this. All you can do is simplify, and it's our quotient rule. And don't forget that there's a hidden exponent in the denominator of a 1. And then number 3 is power to a power or power of a power. Again, the base is y, so I can't evaluate it, just simplify it. And then for the fourth one, there's a little note here on the side. This is number 4 is a subtraction question, and we don't have an exponent rule for subtraction. We have multiplication, we have division, we have power of a power. What happens if the exponent is 0, but subtraction is just collecting like terms. So if I had 3 xy's and I'm subtracting 2 of them, how many do I have left? And this is just a matter of changing the coefficient. I'm not changing the exponents. Adding and subtracting is just collecting like terms. It's not an exponent rule. So go ahead and pause the video, do these questions, and when you have them answered, go ahead and start the video. And I'll have the answers on the screen. You can check your work, and then we'll keep going with the remainder of our exponent laws. So hopefully you have these answers. The first one, the base is 3. The new exponent is 7 because 5 plus 2 is 7. That one does equal 2,187. Number 2 is just y to the power of 9. Again, can't be evaluated. Number 3 is y to the power of 12. And then number 4, you could either write 1xy or just xy because we don't need a coefficient of 1. So just as a review, you guys know that for the product rule, you're going to add the exponents. You're going to have x, a plus b, whatever a and b represent. For the quotient rule, you're going to have x, a minus b. We have these from yesterday. You can just fill them in. For power of a power, it's going to be x, a times b. And then we've got a couple of new ones here. We have power with a rational base. 0 exponent rule, we already know always equals 1. And then the negative exponent rule is what we're going to be looking at today. So we'll fill those in as we go through the lesson. First of all, starting with the negative exponents. So with the negative exponents, any non-zero number raised to a negative exponent is equal to its reciprocal fraction. Hopefully that's a phrase we remember from elementary school. To the opposite positive power. So first of all, let's remember what's a reciprocal. So reciprocal is the fraction flipped upside down. So if you had the fraction 1 over 4, the reciprocal is 4 over 1. If you had the fraction of 3/8, the reciprocal is 8 divided by 3. So it's just the fraction flipped upside down. If you have a whole number, like the number 4, the denominator of any whole number is a 1. So the reciprocal of the whole number 4 is 1 over 4. Because you got to remember there's always a denominator of 1 under a whole number. The opposite positive power means that in this case, all of them have a negative exponent, x to the power of -3, 5 to the power of -2. When you flip it upside down, when you turn it into its reciprocal, you're just going to take the exponent and make it positive. So if I look at my first one, which is x to the power of -3, underneath this -3 is a 1. So when I flip that upside down, so I'm just going to make it into its reciprocal. I'm going to have 1 in the top, and then I'm going to have x to the power of +3 in the bottom. So this is the actual equivalent answer. So we will be always practicing making sure our answers don't have any negative exponents in them. So we want to rectify that. So if I did have an answer that had negative exponents in it, I'm just going to put in the opposite part of the fraction. So if it was in the numerator, flip it down to the denominator. If it's in the denominator, flip it up to the numerator. So again here, underneath this 5 is a 1. Okay, so that negative exponent says, I'm going to flip this into its reciprocal. So I'm going to have 1 now in the top, 5 to the power of +2 in the bottom, which equals 1 over 25 if I actually evaluated it, because 5 squared is 25. So if you guys wanted to double check this answer, if you grabbed your calculator and if you put into your calculator 5 to the power of -2, oops, let me clear out what I had here. So 5 to the power of -2, you can see I get 0.04, but I'm just going to turn that into a fraction. And it's exactly what we just said. It's 1/25. So you can play around with this to try to remember how to do it. If you get stuck, your calculator's a great starting point, and just see what happens as you just play around with plugging things into your calculator. This one, there's no negative exponents. You're like, what's the problem? Well, if we apply the quotient rule to this, we're subtracting. 3 take away 5 is going to be -2. Well, I don't want to leave my answer with a negative exponent. So underneath this whole number is the denominator of 1. So I'm just going to draw 1 underneath it. And then if I flip that upside down, I get 1/x². And because that's just a variable, I can't do anything with it. I'm going to leave it just x². Well, if you look at my original starting question, where did the majority of the x's start? In the bottom. So when 3 of my x's canceled out, where did the 2 remaining extra ones actually exist? In the bottom. So this does make sense in this scenario. If I just applied my quotient rule, I end up with a negative exponent. But when I think about it, 3 of the x's reduced to 1. X divided by x is 1. 2 of the x's were still in the bottom. All of them in the top reduced to the number 1. And this is my end answer, 1/x. So here's some more practice. I'm combining rules from yesterday, so we need to make sure we're comfortable with them. So this is a product rule, multiplication, so I add my exponents. So 4 plus -4 is 0. 0 plus 3 is just going to be 5 to the exponent of 3. I didn't have to worry about that negative exponent. I don't have to flip it. If you flipped it, you would end up with 1/5 to the power of 4. And then when you times it to this 5 to the power of 4, I would actually end up with 5 to the power of 4 over 5 to the power of 4, which is just the number 1. 1 times 5 to the power of 3 is 5 to the power of 3. So I'm just going to use my rules to make this as simple as possible. And then if I was going to evaluate that, I could get this answer. But let's just apply the exponent rules now. So this, I've got to follow BEDMAS. I can't simplify in the brackets, but I do have exponents to worry about before this multiplication. So right here, power to power rule says I'm starting with 3, my base is 3, but -3 times 4 is -12. I end up with 3 to the power of -12, and I still have to multiply that to 3 to the power of -1. Well, a multiplication rule says to add my exponents. So -12 plus 1 more negative is going to be 3 to the power of -13. But I'm going to make sure my answers are not left with negative exponents in them. So I'm going to remember underneath this 3 is a 1. So I'm going to flip it. And I'm going to get 1/3 to the power of +13. 1/3 to the power of +13 is actually my end answer. We could evaluate this. It's going to be a really small decimal. So for now, we're just going to practice applying the exponent rules, but we could plug that in if we really wanted to. So again, I have to follow BEDMAS. I've got to do this exponent, then I'll do my multiplication rule, and then I have to deal with that negative exponent. So you guys go ahead and pause the video and you try these. I'm going to first apply the product rule, or sorry, the power to power rule first, exponents, then worry about the multiplication, and then get rid of any negative exponents that exist. Same with this one. Start with your power to power rule. And then remember, you can only multiply like basis. So once you've applied that power to power rule, the 2 is not going to have anything done with it. There's nothing to multiply to the 2. Just combine the A's using your multiplication or your product rule. So pause the video and you guys try these two. Okay, hopefully you guys have similar answers to what I have. So 3 times -2 is -6. 2 times 2 is 4. And then the product rule, I'm going to add -6 and +4. That gives me -2. I can't leave my answer with a negative exponent, so I flipped it. So I get 1/4 squared, which you guys know is 1/16. We're just going to leave it like that. Here, -2 times -4 is +8. I didn't do anything with this other term because there's nothing to do. I have a 2 and I have an a with a -2 exponent. I don't have to worry about distributing or simplifying or anything. I left the 2 too because in front of this a is a 1. So 1 times 2 is just 2. A8 and A-2, following the product rule, is add your exponent. So 8 plus -2 is 6, and it's just done. 2a power of 6. So this one is simplify, and this is rearranged to eliminate all the negative exponents. So on this one, you could probably do right now, and you could probably in one step just write the answer in the actual appropriate form. But if I did 3 subtract 4, I'm going to end up with b to the power of -1. And I'm remembering that there's a 1 underneath that b. So when I flip it, I actually just have 1/b and just 1b. So I don't need an exponent. If I look up here, I know that's true. 3 of the b's canceled. All of them reduced to a 1. So the 1's in the top. And I have 1b still remaining in the bottom when x1. This one maybe looks a little tricky. So this one, we've got an exponent and a rational base. This is the distribution rule. So I'm going to first distribute it, and then we'll worry about the other rules that we have to apply. So I'm going to end up with a squared, b squared. All I did was distribute the square onto both things. I still have this b to the power of -3. I haven't done anything with. And in the denominator, I have a to the power of -1. Okay, so in the top, I'm just going to worry about the top right now. In the top, I have a's and b's. I can only collect like terms. So the a can have nothing done to it. It's still just going to be a squared. And I'm multiplying these b's. So that means adding exponents. So 2 plus -3 is going to be -1. So I have negatives I've got to worry about. So pretty much all I actually have to do is switch these two in the position that they're in. So I could actually just, I'm just going to move this over. I'm going to try to anyways. I could actually just switch the A in the position of the A and the B. So I can put the B down and the A up. And that would probably be the easiest way to go about simplifying this. So I'm just going to, and when you flip it, the exponent becomes a positive. So I'm going to have a squared still on top. I didn't move it. I moved the a -1 up to the top, so it becomes a +1. I'm moving the b1 down, so it's going to become a +1. The only thing I have to do is combine these. So this is the product rule. I don't have a dot or an X or brackets, but when there is no symbol, it's multiplication. So I'm going to add these. So your end answer should actually be A3 over B. So I'm just going to combine these. A3 over B is your final answer. So these are getting a little bit more complicated, but just think about one rule at a time, and that's going to help us get through this. Okay, so how to power, and then I also have to distribute that. So I've got to put those together, and then I got to distribute these in. Okay, so 3 times 4 is 12. And then I have x -7, y -7. I'm not even going to worry about the y right now. Let's think about these x's. Again, there's no brackets or anything, so this means multiplication. So multiplication is add. 12 plus -7 is 5. And then I still have this negative exponent, the -7 exponent on the y. So what I'm going to do is I'm actually just going to move the y down to the denominator. So the x was still positive, so leave it at the top, move the y down and make it a positive exponent. So that's your final answer. You can't do anything with x and y because they're not like bases. Okay, this one looks messy. So I'm going to follow BEDMAS. I'm going to worry about what's in the bracket, then the exponent. So looking at this fraction here, 1 minus 2, because I've got this division, is going to be x to the power of -1, x3 3. So I'm doing one rule at a time. This is a product rule, it's multiplication, so I'm adding. So then I'm going to have x -1 plus 3 is 2. And then I have my power to power rule. So 2 times -1 is -2. But I can't leave it like that. So now I'm just going to write 1 over. I'm going to flip it into its reciprocal. Underneath this x is a 1. So my final answer is actually 1 over x squared. That's my final answer. Everything's positive. I'm down to just one base. I can't do anything else. That's going to be your final answer. Okay, so now that we've gone through the lesson, there is going to be some practice questions for you to do. Please go ahead and pay attention to what instructions are given and make sure you do lots of practice as we continue layering on our exponent laws and our different skill sets. You can add into, if we go back to this table here, you can add in the two components that we didn't have yet in our exponent laws. So for the rational base, it's the same as distribution. You're just going to distribute the x into the terms in the bracket. I'm going to distribute the variable to the bracket. Oh, sorry, not variable, exponent. Sorry about that. You know, it's running off the page there, but hopefully you guys can see it. And then the other thing we need to add into here is your negative exponent rule, which is turn the base into the reciprocal fraction and make the exponent positive. So go ahead and fill those in. You should have all of the rules now on this sheet. That's going to help you guys as you work through your independent practice. And let me know if you have any questions, and we'll continue with this tomorrow.